Hi, I'm Jefferson. I'm from Brazil, and I will be presenting this work called a multi-agent approach for online Twitter bot detection. Our presentation uses the same sections as our paper. And for introduction, we need to talk about online social networks that are tools which allows us to interact on a large scale with persons around the world. And relevant OSM is Twitter, and that Twitter is common to observe bots acting, spreading spam, phishing, and fake news. We did a previous work researching Twitter bots, and this work is called Reduced Feature Set, Twitter bot detection with reduced feature set, where we constructed on this previous work offline classifier. But here we improved this classifier through the use of a multi-agent system combining three different ML algorithms. We reached average of AUC above 0.98 with a standard deviation of 0.01, which are good results for doing this bot detection. And we ran a proof of concept involving online bot detection with 88% of accuracy. It means that uh, a little bit more than 88% of the bots that were detected by our mass were correctly labeled. And here we are using the approach of computational intelligence that treats the computational intelligence as the construction of intelligent agents. Agents are computational entities which can perceive the environment, create and achieve goals, operate and under autonomous control, persist for an extended period, and adapt to changes. And when we have two or more agents interacting with the environment and among them, we have a multi-agent system. And these bots can interact on a cooperative or a competitive way to achieve a goal. And we are using the tropos for developing our agent-oriented software system. And we choose tropos because this methodology covers all design phases since the initial requirements to the implementation. And here we have the main related work found on the literature. And we have the Rodrigues Luiz, which is the state of the art because it is the newest work found on our literature review. It uses a very good methodology too. It was published on a good journal, and it did offline supervised classification. Our previous work was in comparison with it. We have other examples of bot detection too. We have MASA that focus on finding head-to-head botnets using online unsupervised classification. We have this example of work that does bot detection on the American elections context. And we have Abreu et al. That uses offline trained classifiers for doing online bot detection. That is very close to what we did here, but using the units. For developing our mass, we need to do the prep project of our agents. And this prep project starts with the definition of the P's. P's is an acronym for performance measure, environment actuators, and sensors. And we need to define this characteristics of the agents before we start to plan our mass. The environment used here is the Twitter, and this environment is the same for all the three kinds of agents developed here. The Twitter can be defined as partially observable, non-deterministic, episodic, dynamic, continuous, and multi-agent. We have the piece for the three kinds of agents. We have the agent collector, the classifier, and the referee. And the collector uses the reactive reasoning model because the task of our collector agent is quite simple. It's only collects the tweets and sends its data through the agent's classifiers. Classifiers are learning agents, and because they use machine learning for doing their tasks, and the classifiers classifies the data from the collector and sends this classification that can be bot or human to our referee. That is an objective-oriented agent which computes the majority of votes in a key's decision. We have the troposlate requirements diagram of our mass, and it shows the four actors that acts on our mass. The Twitter is treated as an actor here too, but we have the three kinds of agents that was developed by our team. And at this diagram, we can see the tasks, resources, and goals shared among these actors. Here we have the architecture of our mass, and we can clearly see the workflow followed by our system. Here we have the agent collector, which collects the data from Twitter, and this data is collected through the observation of a keyword defined by the researchers. It sends the data to the three agents classifiers, which use three different ML algorithms. And its classifiers does a classification of the data provenient from the collector and sends these classifications to the referee. Each classification counts as a vote, and this classification can be human or bot, and the referee computes the majority of votes and stores the decision at one database. Our implementation was done using the Python agent development framework, and we used agent communication language defined by the FIPA. We use the subscribe and the inform protocols for doing this communication. And we use the data set provided by Cressy et al. And we use the data about social spam bots 1, traditional spam bots 1, and genuine accounts. And the 3ML algorithm selected for our mass was the random forest, the SVM, and the naive Bayes. They were trained using 90% of genuine accounts combined with 90% of bots. This 90% of bots can be social one or traditional spam ones. And we tested the ML algorithms with the remaining 10% of data. Our feature set was the feature set developed by our previous work, and it's the feature set. It's these 5 features. They are the statuses count, followers count, friends count, favorites count, and listed count. Here we have a comparison of the accuracy, AC, recall, and F measure of the ML algorithms alone and combine it on the mass. And the mass was very close to our best algorithm, which is a good signal. And it shows that combining the 3ML algorithms doesn't affect the performance of the ML algorithms. And in some cases, can occur that the SVM and naive bias can correct an incorrect classification from the random forest. And here we have the comparison of the AUC of the algorithms in the mass. And the AUC was chosen for this separated view because the AUC is a good performance measure for this kind of data set. And because the data set was very imbalanced, we had more genuine accounts than bots. The AUC is a good performance measure for it. And again, the mass kept the performance achieved by our best ML algorithm with a low standard deviation. We have a graphic with the same data from our previous table. We can see that our mass performed well, and it is very close to the random forest, which is a good thing. And after this whole comparison running the mass with offline data, with using the data sets, we run a proof of concept and with the online tutor bot detection tool. And this proof of concept was using our mass with real-time data from Twitter. Our mass was set up with the random forest, the SVM and naive bias trained with the social one and genuine accounts data sets examples. We used the keyword vacina, that means vaccine, and we ran this experiment for approximately 6 hours, and we collected more than 44,000 tweets from more than 31,000 different users. We had an average throughput of something very close to 2 tweets per second in considerably weak hardware for nowadays standards. We found 183 tweets that was published from profiles classified as bots from by our mass, and these tweets were provenient from 144 different users. For validate this detection, we asked for the data of these 144 different users, and the Twitter wasn't able to return this data for us. And it means that 127 suspicious profiles were suspended by Twitter or excluded by their owners. And it suggests that 88% of the users classified as bots were correctly labeled according to Lee et al. For concluding, the main objective of our research here on this work was achieved because we developed a mass capable of detecting Twitter bots, and our architecture was very good on the online detection because our architecture is a pipeline for processing and classifying tweets as they are captured by the agents. And we ran a proof of concept using the online Twitter bot detection, and our mass behaved very well with indication of good throughput and good accuracy of detection.